High Efficiency OpAmps with RF Immunity from New Japan Radio. Hello and welcome. This is Vitor Ribeiro from New Japan Radio Europe. I am Sales and Marketing Manager in New Japan Radio's headquarters in Frankfurt, Germany. In today's session, you will get an overview on NGR's new low-power operational amplifiers and their enhanced features. But before we go into technical details, I would like to briefly show you what our customers consider as key requirements when it comes to an OpAmp selection for a new product development. This is a compilation of what is being considered important and is highly influencing the OpAmp selection process. Out of this list, we will focus on speed, current consumption, and the widely underestimated feature called RF immunity. Let's start with speed and current consumption. In general, you can say the faster you get, the higher the current consumed by, for example, a CMOS device. This is a typical situation for conflicting targets. There is no such thing as a free lunch. If you want speed, you get it at a cost of higher current consumption. However, applying enhanced design pattern and process technologies allows to minimize the current consumption for a given speed. We call these high efficiency OpAmps and comparators. New members of our high efficiency OpAmp lineup are currently under development. The recently introduced NGU7755X, which I will show in more detail in a minute, will be followed by more low power OpAmps with different gain bandwidths and current consumption per channel. Even though NGR OpAmps always used to have excellent low current consumption figures, we managed to improve them even further and to bring our OpAmps to the next level. While previously available OpAmps had, for example, an average current consumption in the range of 330 microamps, we could now achieve an 85% reduction while increasing the gain bandwidth product by approximately 40%. This is an outstanding result and justifies the label high efficiency. Let me now come to the next topic in today's session. RF immunity. What does it mean? How can you judge a device performance? And why is it important? Let's look a bit closer to the subject. RF can enter a system either via conduction or radiation, while the later one most of the times gets converted into conducted EMI. Basically, all PCB traces and IC terminal pins can act as an antenna for radiated EMI. Conducted EMI can enter an IC via the power supply or signal input pins. From the design point of view, the EMI coming from the power supply pins have less of a negative impact compared to the EMI at the signal input pins. What happens in the IC if RF is being input? Well, some of you might remember the good old days of analog radio transmission, where a diode was used as an AM signal demodulator. This is exactly what happens in the IC, where you have many internal diodes capable of rectifying the RF, resulting in generating a DC voltage level, which on the other hand will cause an internal offset level shift. This internal DC offset shift can be seen at the signal output as a distortion. You can easily replicate this measurement by using an RF signal generator, a device on the test and a scope. The results based on NGR's RF hardening are impressive. With most OpAmps available on the market, you will see glitches at the output pins, but there is no negative impact using NGR's RF immune OpAmps. In this particular example, we used 2.4 GHz bursts, which for example could also be created by a Bluetooth transceiver operated nearby the OpAmp. A comparison with popular products on the market shows that our OpAmps achieve a 40 dB better RF immunity at 1.8 GHz. Our latest high efficiency OpAmp NGU77552 shows no glitch at all and demonstrates a superior RF immunity behavior. Why does this matter? Well, today we are already surrounded by RF connected systems such as Wi-Fi, mobile phones, Bluetooth, LoRa, Zigbee, just to name a few. Just count the number of RF connected devices in your room. How many mobile phones, how many PCs and gadgets connected via Bluetooth are nearby. Today, everybody is talking about IoT, which basically means that you have an electronic system wirelessly connected to other electronic systems. When it comes to OpAmp usage in such systems, the task is quite often the conditioning of small analog sensor signals, which need to be amplified and filtered before they get input into an A to D converter. It is important that the signal conditioning has no impact on the signal quality. However, in IoT systems, you have RF transmitters located closely to analog signal conditioning, and it is likely that the OpAmp will be exposed to either conducted and/or radiated RF signals. As we have seen, this RF should not enter the OpAmp, and usually this requires external filtering in order to avoid the previously explained effects. This obviously can be done, but it increases the system cost caused by the external filter components. RF immunity can help to improve the system quality while reducing system cost. NGR is implementing integrated RF filtering as a standard feature to new OpAmps. As you can see, it is already available in low power, precision and standard OpAmps. More information on NGR's RF immune OpAmps can be found in more detail in this app note on our website. Feel free to get your personal copy by downloading this interesting document. Let me come to the introduction of NGU7755X, the first member of NGR's high-efficiency OpAmp family. NGU7755X is available as single, dual and quad channel version with different package options. The single channel version comes in two flavors, supporting chip orientations used by other OpAmp manufacturers. This feature makes NGU7755X an ideal replacement for OpAmps in existing designs. The operating voltage range goes from 1.8 volts up to 5.5 volts over a temperature range of -55 to +125 degrees Celsius. Being a member of the high-efficiency OpAmp family with a gain bandwidth of 1.7 MHz and a current consumption as low as 50 microamps per channel makes this OpAmp highly suitable for all kinds of battery-powered equipment and analog signal amplification and filtering. A datasheet and additional information can be obtained from our website. In addition, you will also find a parametric search where you can get product proposals based on your specific OpAmp requirements. Thanks for watching, and please feel free to contact NGR or one of our partners in case you require samples or additional information.